Hey everyone, I have something here for you on graphing solutions to equations. There are times when it's just tough to solve an equation, and if we can get an approximate answer through the graph, it can kind of help us make some headway. So that's what I'm going to show you here. We're going to look at graphing with the TI84, same procedure with the 83. How can you solve an equation graphically? Now I do want to talk about a couple concerns. And then we'll look at a couple of examples. Now, for those of you who are watching in 2020, especially March, I don't have time to do the whole thing. I'm going to just do exponential equation solutions, but I will reproduce it a little bit later, and I'll have the whole thing here. But here we go. Let's talk about concerns. So, concerns about this method. Now, this isn't concern about the method, but just so you know, the examples that we're going to talk about here are best suited for pre-calculus students, but advanced algebra students who are pretty strong in intermediate algebra could pick this up as well. So I just wanted to point that out. But here are the real concerns. In general, when you're solving by graphing, the solutions are not going to be exact. You're going to have to accept some level of approximation here. The second concern I have for you about solving this way is the most difficult part. It's finding an appropriate viewing window in the graphing calculator. So if you're not too familiar with the equation that you're graphing, you may not see the critical features in the graph, so you'll have to learn how to play around with that. But many of you have been graphing, so you got a sense of creating a good window with the right domain and range. I'm not going to really detail that out here. So with those concerns stated, let's look at this strategy here. Solving an equation graphically. So if we're going to solve x squared minus 9 equals 1 minus x, say we want to get a rough idea of how to solve this. We're going to take the equation and split it into two graphs. So we're going to create an equation that we can graph here, and we'll call that y1, and it's going to be the left side of my equation, 2x squared minus 9. And then we're going to create a second graph, and that's going to be the right side equation. And we're going to graph both of these. So I need to type in the 2x squared minus 9, and that's my first equation to graph. And so the expression from the original equation, 1 minus x, is on the other side, the right side. I'm going to create a second graph with that. And now what I'm looking for is a place where the calculator, I'm going to have the calculator find the intersection. That's what I need to find. And the solution to this equation here is an x number. That's what I ultimately seek. I want to know what the x number is. And it's the x number where the left side and the right side equal each other, which is going to show up on our graph where the two functions cross. And so I'm going to come over here and push graph. And fortunately for us, the standard window is showing a pretty nice view of both solutions. Now, you may not have anticipated that, but we do have a solution over here and another solution here. So that's our next step. How do we make the calculator find those intersection points? And there is a calc tool above the trace button. And we can open up this calc menu by hitting second and then the trace, and it reveals a bunch of calculator functions. One that will calculate the intersection, number 5. So you can either just type number 5, or you can arrow down to number 5, either way, and then hit enter. And it's going to ask you, the calculator needs some information. It needs to know 3 questions. It wants to know what's the first graph, and it's suggesting y1, and we're just going to hit enter to accept that suggestion. It needs to know which one is the second graph. Now notice the cursor has jumped over here to the other graph, the linear graph, and it's suggesting is that our second graph. and we're going to hit enter to accept that suggestion. And then the guess. When you have multiple solutions, we have 2 in our case, you want to move the cursor close to the solution you're looking for as your guess. So I'm going to go for this solution on the right side, and I'm moving the cursor. It doesn't have to be right on it. Approximately close by is good enough. It just tells the calculator to find the one on the right, not the one on the left. And we're going to hit enter, and there it gives us a solution. It says that both graphs equal -1 for the y when x is 2. So we can tell what the solution is. So x equals negative, nope, it's not negative, x equals 2. And there's another solution. I'm going to go back and I have to repeat the calc menu. Go down to number 5 again. And this first curve and second curve, it's only important when your calculator has got many equations in it, because it doesn't know which ones to use. But for us, we only put in 2 equations, this first one and the second one. So we can just go enter and accept both of those equations. But the guess this time, I have to get this cursor moved over closer to the other solution. Okay, so it just has to be kind of past halfway to be close enough. Now it's going to find the intersection point, and it does find it again when up here at 1, 2, 3, both graphs are at 3.5 when x is down here around -2.5. So I've got 2 solutions here. Now, if I were your teacher and you were turning some work in for me, I would want you to give me the equations. I would want to see these equations that you're using. I'd want to see a rough sketch and a scale that you're using. And we're using the standard scale. And I'm looking for not perfection, but just a rough sketch, so I kind of know what you saw that helped you get this solution. So notice it's not beautiful, but it's rough, and it would be enough to communicate to me that you knew what you were seeing when you saw it. And the last thing I would want to know is these intersection points. So -2.5, 3.5. And this one, I didn't write it down. I'm going to try to do it from memory, but I think it was 2, -1. And that gives us the 2 solutions. So I kind of see now what you saw, and now I know why you're saying these are the solutions. The advantage to this method is it's really easy. The calculator does all the work, provided you can see it all in the window. Let's do another one of these. Let's go here, and let's get a new screen. Now, this one actually is a little bit more advanced, because not only are we going to be solving an equation, but we have to create our model for it as well. And so some of you that are studying exponentials, you're familiar with them, and you could create your model. But I'm going to define some variables here. T is for the hours. And this is about the amount of caffeine. So caffeine in the body is getting consumed at a rate of 17% per hour. And once the blood levels show caffeine to be about 20 milligrams, the person tends to not notice the caffeine anymore. Now, it says that we start out with a cup of coffee. So I should add hours after the start, but I'm not going to write that down. We do have a starting amount. So when we start our cup of coffee, we have 100 milligrams of caffeine. And so it also is a continuous rate of decay. So we're going to be using the exponential base E. And I probably should have written down one more little fact, but I'm kind of crowded here. The R is negative 0.17. So the rate is a decay rate because we're losing the caffeine. So with all those facts, we can write an equation here. Or let's write the function model first. Here's the caffeine equation. It's going to be 100 for the starting coefficient value, E to the minus 0.17 times T. That is our equation to model the caffeine decay in the body. But we had a second job to come up with, and that was to solve. When does the caffeine equal 20 milligrams? So we're going to have to plug that in and solve this equation. So we're going to have minus 0.17 times T. So the time is what's unknown, and that's what I've got to solve for. So if I were to solve this, it would require a knowledge of how to do an inverse function of an exponential. Now, when you're first studying exponentials, you don't know what that inverse is. So when you're first studying this, we actually don't have the algebraic tools to solve it. Now, shortly after you study them, you learn about logs and you can solve it. But let's say we want to solve it graphically, because either we don't know about logs yet, or we just want to check our solution. If we solve it by algebra, we may not be sure that we got the right answer, and we can use the graphing method to help us solve this. So I am going to make two equations. y1 is 20, and y2 is 100 e to the minus 0.17 t. Now I have to translate the t into the graphing calculator as an x, because the graphing calculator only does functions of x and y, but these are what I'm going to graph. And so here we go. Let's go to the equation. I'm going to clear the old ones, and I'm going to type in 20 for the first equation. Now you may recognize that's just going to be a horizontal line. And then the other equation, 100, now right above the division button is my exponential base E number. I'm going to use E, and then I'm going to raise it to a power. There's the exponent command. And since I have a multiplication here, I'm going to put it in parentheses. It's negative 0.17 times x, close the parenthesis. And now I've got both sides of this equation into two graphs. Now we do need an appropriate window. Now there's some things we're going to need to know about this, but one thing we can know is time is greater than or equal to 0, so that helps me with the window. Can't have negative time. That doesn't make sense. So when I'm setting the window axis, I'm going to start at 0. And I don't know how big the number is, but we're talking hours, right? So how many hours is a cup of coffee going to last? I actually don't know. So I'm going to start with 10. I'm just going to leave the 10 that's there before. I'll leave the scale as 1. Now, can I leave the caffeine from negative 10 to positive 10? Well, first of all, you can't have negative caffeine in your body, so that wouldn't make sense. But I could have 0 amount of caffeine, 0 milligrams, so I'm going to make my minimum caffeine amount 0. And how much maximum caffeine? Well, you may recall that the problem said that we're starting with 100 milligrams and we're going down to 20. So when I'm looking at the y's, it's got to be at least 100 as a max. But if I put 100 as the max, that'll be at the very, very top. So I'm thinking I'm going to maybe make it like 150, just a round number, so that I can see the whole thing here. And I think we'll count by 20s. And now let's graph. There's the 20. And now we're seeing the exponential function. The decay is coming down. And we do see an intersection, kind of, sort of. I am not really comfortable with that intersection. It's not a clear cross point. So that tells me when I went out to 10, maybe it wasn't far enough. So I'm going to go back to the window. Remember, I was just guessing on 10. And now I'm going to make it go up to 15. Also just a guess. But I think it'll cross at this point. So let's graph and see what happens this time. All right, so there, clearly I can see where it crosses. I can get the intersection. And I'm going to go to the calc menu. Second, trace, to open the calc menu. I'm going to go down to the intersect command. And it's going to ask me all these questions. Enter the first, enter the second. And there's only one solution, so the guess isn't that critical. I'm just going to hit enter again. And now it tells me when both y's hit 20, the x solution is what I want, 9.46. So I'm going to round that off and say it's not x in my model here, it's t. So I'm going to be able to say, so t is about 9.5 hours. I hope that was helpful for you. It shows both a model for exponential plus how to solve it graphically. Study hard and practice. Use this graphing calculator as a way to check your algebra. Good luck with this, and I'll see you on the internet another time.